So let me give you a quick intro to my demo. So what we are going to do in terms of cloud bursting is we have a notion of a CI/CD pipeline. So how it works is a developer is going to write some code, commit the code to their source control repository, let's say GitHub in this case. That's going to trigger a webhook, which is going to add the job to build the code written into a build queue. And what we have at the very bottom is a bunch of builder pods, which read jobs out of the build queue and sort of like run the builds and deliver artifacts. And these builder pods are managed by Kubernetes. And to start with, we're going to start running these on a private cloud. Okay, and I'll talk more about the dashboard as we go along.
One qualifier before you dig into this here. So
Sure.
We were talking earlier about the OpenStack API that you're interfacing Platform9 with. Okay, so now we're talking about Kubernetes. Did we
Yes.
shift gears in communications, or am I still talking OpenStack API, then Platform9?
No, so, okay, maybe I should have prefaced that. We have two product lines in Platform9. One is called the Platform9 Managed OpenStack, which I think was where Jeremy's initial sessions or the Omni session was centered around. And what I'm talking about is the Platform9 Managed Kubernetes. Yeah, sorry about that.
So now
Yeah.
I'm using Platform9, and now I'm talking Kubernetes.
Kubernetes, exactly.
So at the IaaS layer, you're talking about the OpenStack APIs. At the container orchestration level, you're talking about the Kubernetes.
We are now at the microservices layer, which...
Now you just confused me again. So when I'm controlling this environment, if I have Kubernetes at my orchestration layer, am I still talking OpenStack higher up then?
You don't need to. You can just directly talk to Kubernetes.
Okay.
Yeah.
Are they completely separate, or do you see a world where you have OpenStack APIs that your Kubernetes management calls OpenStack APIs to manage the VMs that Kubernetes runs on, in effect?
So, yeah, sorry. Yeah, we do envision a world like that where we are able to leverage OpenStack itself to deliver Kubernetes sort of resources.
So just different layers of the stack.
Yeah.
That's right.
So, yeah, if you want to talk IaaS, you talk to the OpenStack. If you want to talk microservices, sort of container sort of workloads, you talk at the Kubernetes layer, but there's also the notion of Kubernetes itself leveraging OpenStack to deliver various things like persistent volumes. I know I didn't go into any more of those deep Kubernetes concepts, but yeah, there is a notion of, we do envision OpenStack being one of the possible cloud providers for Kubernetes. Okay, so let's start with the demo. So what I have here is like a simulated build dashboard. So I have an option of submitting jobs, or in this case, sorry, submitting commits based on what the initial diagram had shown. And today, right now, you can see that there's 0 jobs left in the job queue. So it's like the builders are able to process the jobs or whatever the builds that are needed at a fairly good rate. And the commits are pretty okay. But now let's say we have a scenario where you're going to have developers start committing code more often. Okay, so let me increase it to say commits is about 7. Okay, now you should, over a period of time, we should see more jobs getting queued up because the builders are processing the jobs, but the commit rate is faster than the rate at which builders are building stuff. In the meanwhile, let me also go and show you a bit about Platform9 UI itself while the job queue is building. So this is, once you log into Platform9 Managed Kubernetes, you have this infrastructure view where you can see your clusters, which Kubernetes clusters which you have created. You can also see that these clusters which I've created are local, and local 7 is the cluster of interest for this demo. If you were to go to nodes, you will also see what all are the nodes which we have added to this cluster. In this case, local 7 has like 2 builders running on it. Okay? Then there's also a notion of federation. Remember the federation control plane which I built? I've already added that into the controller, in the Platform9 Managed controller here. And today you can see that at the moment it has only local 7. That's the local cluster as part of it. I also wanted to show the pods view, and you can see that we have like 6 builders today. If I were to filter it on, builder, we have 6 builders which are actually doing the job of building whatever commits are being committed at the moment. Okay. Looks like this is the graph is. Let me just refresh this because or maybe I'll do a 20 so that I build up the queue. So yeah, basically what I'm waiting for is the job queues to start growing. You can see that the job queue length is beginning to increase as more developers are trying to commit the code. And it's starting to increase fairly rapidly. Now what's happening is the build rate is not keeping up with the commit rate. So you actually have a lot of commits going in than what the builders can handle. Just to maintain the graph part of it, let me tone it down to about 13. Now, what options do I have here to solve this problem? One way is to ensure that I can create more builders, but then if I were to go to the nodes view, and let me just refresh this, you'll see that the builders are already building to the max. They're already maxed out on compute, sort of a thing. And I don't have any more free builders at the moment to add to this. So maybe I have to do something else. Okay. Let me go show you a few things around what I wanted to show is, let's say I want to do a tail, for example, to show one of the builders. And you can see that I'm basically tailing the logs of the builder. You can see that the builder is actually building stuff over here. Maybe I can do the list of all pods that are running locally as well. There are 6 pods running locally. That's the bottom left screen. And I will come to this pod later on, this point later on. Okay. Now let's see what type of federation I have set up. So if I do the federation get RS, you can see that I have a replica set created for builders, and I've set the desired state to be 6. Okay. If I do klocal get RS, this is based reaching out to the local cluster. You'll see that again, the local cluster has the federation, has the replica set with the desired count of 6, and the current count also has 6. Okay, now what I'm going to show next is basically we have a maxed out local private cloud capacity, but I also have a Google Container Engine cluster in-house. So I'm like, okay, I have a cluster here, and it has 4 CPUs, which looks fairly good. It's like, maybe it can offload some of the builder load which I'm having at the moment. Now, how do you do that with Platform 9? Now, what I'm going to show is more like a preview of things. We have basically added support for Google Container Engine in Platform 9, and it's as simple as going and adding a new cloud provider. We had AWS till date by default, and you can choose a Google Container Engine, choose the file. This is basically the account service JSON file which any Google Cloud Platform is going to give you. And let's say save. Oh, sorry, I had to give a name. GKE clusters.
Sorry, is there a difference between the implementation with Amazon and Google? With Amazon, are you using Amazon's native container runtime, or are you managing Kubernetes with an agent running on Amazon? Because you're not managing Kubernetes on Google. It's Google's container.
Yeah.
runtime.
So for the AWS case, we have a slightly different strategy where we are actually creating EC2 instance nodes and building our Kubernetes cluster on
because
it. Yeah,
Kubernetes
exactly.
Google, so it's native containers for Google. Okay. Yeah.
Okay. So once I did that, you can see that what Platform 9 went into the GKE account and slurped up all the information which is tied to that account. So if you were to go to clusters and refresh, you can see that the Google Container Engine clusters appeared in Platform 9, and so did the nodes. Now, let's see what's happening with the build dashboard. Okay, the job queue has gone up to 28, which is like pretty high. So let me go and add the Google container engine cluster to the federation. That's cluster 1. Do add. And that's it. That's how you actually kick off the federation part of it. Now, let's say I want to do gke-get-w pods. So once the federation actually kicks in, you should be able to see that what's happening at the federation control plane level is that the federation control plane realized that there's one more cluster in the picture, and there's not much utilization happening in that cluster. So it kind of tore down some of the builders which are there on the local cluster and started creating them on the GKE cluster. So this is more like the builders on the private cluster were running out of resources to do their job. So it sort of like started distributing the workload into the public cloud. Okay. So that's that. Now, you can see that previously the builds per minute were about 2 to 3 to 4 builds per minute. Now you can see that it's actually shooting up. It's about 6. I think it should go up. Yeah. And over a period of time, you'll see that the build queue will start to get drained, and you'll be able to keep up with the commit rate of whatever your developers are having. So that is the demo which I had. Any questions around this?
I don't have a question on the demo, but I'd like just from
Sure.
because you can span Kubernetes clusters, in fact, anything that's bursting to the public cloud, that was always the promise of private and public cloud. Of course, we're going to burst into the public cloud. It's going to be scalable demand for when sales ramp up at Christmas. Are people actually doing it? Do you have customers that immediately are going to go, this is fantastic. Of course, wherever my data is, I'm going to be able to do this.
Interesting question. When I actually saw this, I had a similar thought. It's like, I've heard about cloud bursting for about 5, 6 plus years now, and it sounded like a cool concept. I've never seen it in practice. I'd never seen it in practice. Maybe there were some people who actually did it, but I'm pretty sure they glued together a lot of things. It was very complex, fragile thing. But with something like this, I was just amazed that we could do it as easily as this. And we do have customers who talk to us about it. I think it's going to become a thing pretty soon once you can show that it can actually be done in a pretty simple fashion like this.
Yeah, and to talk about it from a customer perspective today, we have that whole range of customers from a startup up to the enterprise today. The enterprise likes to talk about cloud bursting. They like to say, yes, we want to do that, we're ready. They also have a lot of legacy code that they're pulling forward, and they're not as agile and nimble and have the capability to develop that. Where we see a lot more of this practice coming into place are those smaller, agile tech companies that are young. They can start right out with a microservices-based architecture and don't have to tow all that legacy movement forward. So you're seeing the newer companies be able to handle things like this, and then we're seeing a kind of a slow trudge by our enterprise customers into this space. So when they can re-architect, they start to use it and take advantage of it, but it's not like you can just take that legacy ERP and throw it into a Kubernetes container and say,
I don't think it's also just legacy companies. Data is difficult to move around. It's seconds to spin up a container anywhere, but that's got to talk to some data that can't move as nimbly.
So the way I like to think about this is this can easily be, not easily, but this can be done for cloud native applications. And so we are working with a customer. It's not in production yet, by the way. So they are a company who does computation and do the genome sequencing. They have a set of servers, a lab or a data center locally. They compute certain things there, but at times they want to use the public cloud. The way they have solved their data gravity problem is they always replicate their data to S3. So they are in AWS, they have local storage, and they always replicate. They are not under time pressure, but they want to compute certain things in next 3 days because their computation jobs are really long. And from time to time, once they use up their resources on local servers, they burst up to the public cloud even use spot instances, which are half the price of your reserved instances to save costs. So they do all of this optimization to use both public cloud as well as the private cloud. And we're working with them. It's, as I said, it's not in production yet, but we are working them on two fronts: the federation as well as the spot instances pricing.
So there's a lot of upfront cost in that model. When you start looking at your newer capable technologies and cloud-native applications, you start to see how the world is changing around this too, and database technology as well. Cockroach DB is one of these, call it a game changer in database technology, if you will, but it's a sharded database that runs inside of Kubernetes clusters that replicates itself as it comes up and grows. They called it Cockroach because you can't stomp it out, essentially. And with that, you're leveraging persistent data stores in the clusters you're working with, but the actual database layer application is sharding itself and balancing itself as it grows and changes. So technology and data technology is also shifting to allow us to adapt even more quickly to these types of frameworks.
So that's two things that you are seeing customers maybe doing cloud bursting, and also the data is being solved by potentially having the same data set across multiple clouds and it self-replicates.
Or sharding, like Jeremy was pointing out.
So I think we also heard something yesterday of a company doing analytics that they would then take a subset of their data, they could move that out to the cloud, that would cost them, but the data ingress into the cloud was cheap, they could run the analytics on it and then throw the data away.
That's right.
So yeah, I can see a link with that.
Do you see customers that have lots of those use cases, or generally they've got a specific use case where they need, burstable capacity for one application that's generally inconsistent or something, that this helps them with?
It depends on the customer, really. So we operate with a lot more tech-based companies or like ad tech companies as well, and they have a lot of cloud bursting for very, very unrepeatable or
Hard to predict.
Yeah, unpredictable type of workflows. Where you see more of that predictability are things like your enterprise point of sale, your enterprise finance, quarter close, those type of services. And we don't have a ton of those today. We see a lot more of those unpredictable models that we're working with.
Okay, so what's your pricing model?
For on-prem or for hybrid, both?
Let's say so I could do bursting. Because it seems to me if I'm a CIO, I'm now calculating in my head, okay, what would it cost me to have additional spot instances plus whatever it would cost me for Platform9 versus I'll have a couple extra servers in my data center for extra capacity.
So we charge per core that you add to Platform9 Cloud. So the pricing is based upon that. If you are using virtual machines in public cloud, we have a formula by which we calculate what a physical core corresponds to in terms of vCPUs on the public cloud. So it's, I think, 1 to 10. So if you have 10 vCPUs, we say it's 1 core. And so we have pricing based upon that.
Okay.
And I think there's another part which you'll also see is it's more about the mindset change. I think it is probably more relevant around the serverless space. People need to, I think it will become more prevalent as people start thinking about, I need to build apps or use technologies which can leverage the sort of a cloud bursting model of things.
Yeah. I think if I have to summarize it, I should say it's for cloud native applications. So if you're writing a new application with those things in mind, you'll be able to architect specifically using constructs like these.
But in my mind, if I'm building this on a cloud-native technology, why wouldn't I just build it on the cloud and have it be completely elastic and have nothing to do with on-prem?
Well, you're also trying to save cost as well at some point of time because you do have physical capacity, and this is one technology that will give you.
Right, but what I'm saying is I won't need that physical capacity anymore. If my application is completely elastic where it can grow, and then when I'm done with it, shrink it back down to the right-sized instances, that's cloud-native. Why do I need the on-prem capital expenditures in the first place?
Well, I think it would be much cheaper for you.
Okay.
So, especially on container side, I know there was a comment around servers. Mm-hmm. So if you look at containers, the way they run in public cloud, you have to run it in virtual machines. Versus on private cloud, you can actually run it on bare metal. Now, you have an advantage running it on-prem because you will be 20%, 30% more efficient running on bare metal. You can get more out of that bare metal, and you'll be paying more on public cloud for the same capacity, for the same CPU, for the same amount of memory. So you have an advantage running it on bare metal. So if you have a fixed cost, so if you have it already data center, use it and burst to the cloud when you need it.
And that value prop that Platform9 is bringing in as well is if you have capacity laying around, say you're not a brand new company, you've already invested in some sort of hardware infrastructure, you have it laying around in your data center, we can consume those and turn those into your clusters. You don't have to go buy new. We'll take your old, your unused, your forgotten, and we will.
But to me, that seems like that's more of the enterprise solution that you're not currently targeting. You're targeting the new startups, which
we're targeting
building cloud
the scope. The new startups are the more adaptable and agile to move quickly into this space. The larger enterprises are still making those moves. They're just taking longer, and it's not all of their applications that go at once.
Okay.
On that price point, we have an interesting case study, and I would encourage everyone to read it on our website with a company called Spubmatic. They actually moved a big set of, or I think all of their workloads from AWS to on-prem because they had cost issues and they had performance issues. They are very jitter-sensitive application. They cannot tolerate noisy neighbor, and they were able to move to private cloud and actually save money in the long run.
Okay. So moving on. So what the demo actually showed at the end of the day was basically we burst into GKE. We were able to schedule builds across both the private cloud as well as the public cloud, in this case, GKE. There's one other small demo which I wanted to show is around application catalog in Platform9 Managed Kubernetes. So Kubernetes is very developer-centric product at the moment. A lot of the users of Kubernetes interact with Kubernetes in terms of the CLI, kubectl. And if they want to create a resource or they want to do anything with it, they actually end up basically having to write this YAML file, which is like a specification file. And that YAML file can get pretty cumbersome, overwhelming, depending on what you want to do with it. For example, if you want metadata for your deployment, you need to add that. You need to add which pods you want. You need to add how many replicas you want. Oh, you want to use a persistent volume. You need to add that information. So things get pretty complex, and they expect it to be in a certain format, in a certain scheme of things. Now, wouldn't it be easier if things were simpler to deploy, say, a Kubernetes workload? I mean, who doesn't like things being simple, right? That's where Platform9 has integrated an application catalog into the Platform9 product itself. This is based off of Helm. Helm is more like a packaging abstraction which is built on top of Kubernetes workloads. So what you could do is, let's say you want to deploy a Kafka messaging queue service. So it's as simple as selecting it and saying deploy. And internally, this is going to go and deploy the Kafka service, or sorry, the Kafka workload for you. It's probably going to take a couple of seconds. And in the meanwhile, you should be able to go and see what's the status of that. So we have a web CLI built into our product where you can go in and do all the Kubernetes commands. So if you do Helm list, you can see this is called Laughing Turtle, where there is the Kafka server going. I can do Helm status. And that's going to basically tell me about the pods and what all is the deployment and how to use it. So what this has actually led to is basically being able to deploy Kubernetes workloads, which are there in the public space, easily through Platform9. Today, this is using the public Helm catalog, which is there. We're going to add support to do private catalogs in case you have your own Helm catalog available. And another thing which I wanted to call out is with the way Kubernetes does resources and how it delivers its capabilities and the support of cloud providers, this application catalog should be able to work across your various clouds, be it AWS or GKE. The catalog, the deployment in Kubernetes will work in terms of, it should seamlessly map resources to the right public cloud based on where you deploy it.